have Corrado from SAES, which I have to say, of course, we're very happy to have here. I don't need to say much about Corrado. He has extensive experience on the technology development as well as technology lead. So I leave it all to you, and thank you very much.
Okay. Hello, everybody. Now, with my presentation, we look at the hardware systems, and we will focus on some solution already available and maybe that could be useful for the development of quantum computing, in particular in looking at the technology of ion trapping. But let's start from SAES Group. SAES Group is an Italian company located near to Milan that since 8 years provide functional and advanced materials typically to the market of high technology. And research and innovation were already very important for us. We have big labs, more than 3,000 square meters, 150 people working in general on research and innovation, and we have 150 active patents family. We published more than 200 scientific papers during our life. But the reason why we are so committed on science is clear. We are an Italian company. We have manufacturing sites in Europe and USA. Therefore, we cannot compete in commodity markets. We need to provide high-tech solutions for very challenging requirements. And our markets, as you will see, are typically in the high-tech. At the end of the 2022, we had 250 millions of euro turnover and 1,100 employees and 10 manufacturing sites in Europe and USA. The big markets we serve, we have more than 2,000 customers, big at age, healthcare, medtech, consumer electronics, security and defense, automotive, aerospace, therefore, where high-tech solutions are needed. Okay, but looking back at the history of the company, we can see that there is a clear parallel between the evolution of a lot of devices in electronics and similars and the ability of SAES to produce material solutions able to improve or sometimes enable the above device evolution. Starting from the beginning, in the 40 and 50, there was not only the production of the thermionic valves for radio, but also, in particular, the development, the booming of the cathode ray tubes for TV. And SAES invented the so-called evaporable getter based on barium alloy, able to create a film inside the bulb, glass bulb of the TV tubes, maintaining vacuum. Be aware that all the TV tubes we had, the cathode ray tubes we had in our homes for watching TV up until 20 years ago, operated because there was a getter manufactured by SAES. We had 95% of the global market in Europe, Asia, America, and so on. Then the evolution, we developed also different type of getter based on zirconium and titanium, metal dispenser for lamps. But in the 70s, more or less, there was the acceleration of creation of big machines for physics, like in Geneva, LEP, and then LHC. And the requirements was to reach a very, very challenging vacuum level. And with our getter pumps, we are able to reach a pressure of the order of 10 to minus 11 millibar. Then, on the contrary, the rising of microelectronics required a very big miniaturization of our products. Therefore, we were able to produce thin film of getter, even to be deposited in pattern on silicon wafer, for example, for MEMS application. But not only vacuum was the focus, we also have a division working on shape memory alloys for medtech and for industrial application. After the 2000, there was the rise of organic electronics. No more metals, no more alloys, no more high temperature of processing. We developed composites, nanomaterials, able to produce dispensers, sealants, scavengers, fillers, adhesive for application like OLED and a lot of different application in the organic electronics. Therefore, you see this parallel. We want to continue along this path, and maybe also quantum computing could be an interesting goal. And now we focus on 3 possible interesting solutions in this field. First of all, ion trapping requires vacuum. As you have seen, vacuum technology is our core competence. We produce a wide range of chambers, for example, also for quantum interferometer. Also, we are working with AQT, ion Q in the field of quantum computing. We also are able to provide to the market vacuum pumps to reach 10 to minus 10 millibars of final pressure. And in particular, this combination of getter and ion pump is very interesting. Why? Because getter pumps, after the initial activation, operate for months, even for years, without any power supply. They have no vibration, no production of particles, and also no magnetic field. Our ion pump, using a rare earth magnet, have a very small magnetic field. Therefore, it's possible also to mount this pump directly into the chamber, improving the final vacuum. From the point of view of the vacuum chamber, we are not only provider of standard solution, but also we can design with our customer and produce customer-made chamber. And this is also could be a very interesting solution because typically chamber for ion trapping is quite complex. And finally, as told before, also the magnetic interference is very reduced and there is no particular noise from this point of view using our vacuum pumps. This is the first possible solution interesting for this market. Second point is the sources of pure metals. We, since many years, we produce a dispenser. We started with mercury dispenser for lamps in the 70s. Then we move to lithium, cesium, and other kind of dispenser. In particular, we have the availability of rubidium dispensers, and we are working on the optimization of strontium dispenser. Rubidium and strontium are 2 metals typically used in the quantum ion trapping technology. We have dispenser complex with active material inside, but we can provide pills very easy to mount into the source or into the oven of the ion trap. And we also checked with quartz crystal monitor and AFM the very precise control of the release of pure metal by our pills and our dispenser, with also very smooth film where films are needed, and in that case also the difference of 8 of the film in the nanometer scale. Third, lasers are used in ion trapping, and we know that thermal management is one of the issues in using lasers. For many years, we produced composites based on tungsten and copper with good performances, but even to be optimized for a lot of different market applications, lasers, RF devices, microelectronics, aerospace, and so on. recently, and we provided products in form of submount, fiber, microchannel, and so on. Recently, we developed an aluminum diamond composite, and we reached very, very interesting performances, because it's possible to see that the thermal conductivity is very, very high, and also we was able to obtain the thermal expansion coefficients very, very precise for the submount application in the case of lasers. Therefore, vacuum, pure metal release, and thermal management. These are our already available solution, and the message is stay tuned about our development. Also, in the stand in front of the door, you can see some pumps. We can also talk with a colleague of mine about this solution. And SAES is certainly a well-known player in the field of this kind of solution of materials. Last but not least, in this event, also startups are present, and is interesting, I think, to inform you that this year, in 2023, SAES started with the technical accelerator. And what is the distinctive point with respect to a lot of solutions present by company or public accelerator and incubator? Okay, we provide grants, we provide the mentoring, we provide professional support by our IP and legal, but in particular, we provide inside our labs. And as told before, we have state-of-the-art labs with a lot of processing tools, analytical tools, some scale-up pilot line. And we know that for a startup working in the material science, the scale-up is a very big issue. Our program is divided into 2 phases. The first phase has 3 months duration, and the goal is to produce a proof of concept. Then, if our committee approve the shift to the second phase has a duration of from 9 to 12 months, depends on the kind of project in specific. And the final goal is an MVP, and an MVP that is demonstrated to be scalable also to mass production. And the final goal for us is to create business in a form of relationship supplier to customer, and supplier could be startup or customer could be startup, or even to have a partnership and produce something together and go to the market. Recently we closed the second call. Typically we highlight 4 or 5 vertical with very specific technical categories. For sure, in 2024 we will have 2 more calls for applications. Therefore, stay tuned on Red Zone by SAES. And then here you find our website, Red Zone by SAES. And in my opinion, I think in one of the 2 calls of next year, future quantum computing could be a vertical for application of startup working on this field. Thank you.